over it again. Okay, here we go. Listen. Here we go. So when dealing with domain, different teachers teach it differently. Here's what I found to be the easiest, just looking at it algebraically and looking for problems. Now remember, there's the two possible problems. Okay, domain means possible x values. We can plug in any x value, except if we have a radical, we won't have negative numbers underneath, correct? So that would not be in our domain. Does everybody understand? Then once again, we will not be able to divide by 0, so that would not be in our domain. Anything else would work. So, here we go. Given f of x is this, and g of x is this, we're going to find g of f of x and then state the domain. We're going to start out basic and then work our way up. So that would be plugging f of x into function g wherever there's an x. So that would be 1 over the square root of x minus 2. Does everybody agree?
Yes.
Now what you're going to do is pick out all possible problems. So I want to point out something. My first possible problem is right here, a denominator, correct? So I'm going to go make little bulletin points and make a true statement. Isn't it true to say the square root of x minus 2 cannot be 0?
Yes.
Okay, I'm going to make another bulletin point over here. My next problem is coming from here. Isn't it true to say x minus 2 must be greater than or equal to 0? Find the domain on both and then put the domains together. Here we go. Let's solve here. Square both sides. Root cancels out with power. X minus 2 cannot be. So then x cannot be 2. Okay, moving on. We'll put them together in just a second. I'm going to circle that for a second. Then over here we would add 2 over. So x must be greater than or equal to 2 right here. Now we need to put the two domains together. It has to work for both. So we know it's definitely from 2 to infinity, correct? Greater than or equal to 2. So our domain will be from 2 to infinity. Now originally right here we are saying can equal, but right here didn't we say it can't equal 2? So then we would just put a parenthesis and there's our domain. Was that pretty easy? Okay, let's do another one. Okay, let's do this one. Are you writing it down in your notes? So given f of x is this and g of x is this, we're going to find f o g of x and state the domain. Now guys, I'm going to go back. Understand, I didn't finish simplifying this. Because right now I'm just focusing on teaching you domain. We would need to rationalize the denominator, wouldn't we? I'm not going to take time today to do that. We're just focusing on domain. Okay, here we go. F of g of x. So we know we'd squish x back in with g. That's g of x. Squish it back in again. F of g of x. So that means we're taking g of x and plugging it in right there. So don't we have 1 over x minus 5 plus 2? Let's locate all the potential problems because it's going to be, this is my first problem, am I right? So we'd say x minus 5 plus 2 cannot be 0. Solve for x. So won't that be x minus 3 cannot be 0? So x cannot be 3. Now think about it. To write that in interval notation, if that's the only x value we can be, we've got to connect all the other x values into this, correct? So we're coming in from negative infinity up to 3, not including 3, union, then after 3 we start again and go to infinity. Now what's going to happen is in calculus, you're going to be given this and asked to perform calculus, which we'll learn later, of this, and you're going to have to think about what the domain looks like so that you know what the graph looks like. So don't we know it's going this way forever and this way forever? And then as it comes up to 3, there's got to be like an asymptote, right? It's not touching 3. So it's either going like this or like this. Does everybody see how that would be helpful to know? Okay, cool. Moving on. Okay, let's do another one. This is the level that you saw on the homework that a lot of you were getting wrong, I noticed. So here we go. Given f of x is equal to the square root of x plus 1 and g of x is equal to x squared minus 1, find f of g of x in the domain and g of f of x. Let's write that down. Okay, let's write out what this one is. So this one's taking g, plugging it into function f wherever there's an x. So we have the square root of x squared minus 1 plus 1. Before you simplify anything, you need to restrict or look at the domain. So where's the problem? Underneath our radical, correct? So isn't it true to say, okay, we know for a fact x squared minus 1 plus 1 must be greater than or equal to 0. So now we have x squared must be greater than or equal to 0. Now when solving quadratic inequalities, you can't square root it. You've got to solve by factoring and then testing it on your number line. So x squared factors to be x times x. So aren't my zeros 0 and 0? So now make your number line. 0 is my 0. So test below 0. Let's plug in negative 1. Negative 1 squared is 1 greater than or equal to 0? So yes, this is in our domain since that was a true statement. Let's plug in 1. 1 squared is 1. Is 1 greater than 0? Yes. Now, is it equal to 0 okay? Yep, it says right there. So this is also a yes. So my domain for this one is negative infinity to infinity, which notice this one happens to simplify to be x. That's domain. But it won't always work out that way. Just happened to in this one. Because watch the next one. Is everybody good with that first one's domain? Let's do the next one. This one's the one that people simplified and then found the domain getting it wrong. You take this one, plug it in here. So we have this, the square root of x plus 1 squared minus 1. Before you simplify, you have to state the domain. So look right here. Isn't my true statement x plus 1 must be greater than or equal to 0? Solve for x. It's linear, so we can just solve. X must be greater than or equal to negative 1. Wasn't that the only restriction? So our domain will be negative 1, bracket, because of the equal sign, to infinity. And that is our domain. Even though it does simplify to be x, this is our true domain. Questions? Okay. So if you were getting those all on the homework, hopefully that makes more sense. Let's do another one off the homework. So you had 3 over 1 minus 2x, and then g of x is equal to 1 over x. Now, obviously, the algorithm in Math Excel kind of changed up the numbers for some of you, but it would have been the same type of problem. So here we go. Doing f of g of x. I'd be taking g of x and plugging it in here. So let's write what we're looking at. 3 over 1 minus 2 times by 1 over x. Am I right? Now there is this is a hard one. There is 2 potential problems here. The first potential problem is this denominator. Make a bulletin point. It's true to say 1 minus 2 times 1 over x cannot be 0. Now second bulletin point here. Isn't there another division variable? So my second restriction is for that one. X cannot be 0. Because if it was, 1 divided by 0 is undefined, and then we have some weird undefined going on. Because everybody sees. Now let's continue. So we know we're going to piece it together in a second. Solve for x. So we'd subtract 1. So we have negative 2 over x. Why? Because I multiplied that in. Subtracting 1. So negative 2 over x equals cannot equal negative 1. Am I right? What would I do next? Times by x, everybody. Let's get our algebra up there. So what should we do? Times by x. So now we have this. I'm going to skip down here. We have negative 2 cannot equal negative x. So x cannot equal 2. So now look at our restrictions. We're putting them together. X cannot be 0 or 2. Can it be anything else though? Yeah, so let's connect all those x's together. So think about it. We're coming in from negative infinity up to 0, not including 0. Union. Now, between 0 and 2, all is good, correct? From 0 to 2, all is good. And then union, from 2 to infinity, all is good. There's our official domain. So that would be, think about it, that would be connecting everything except for the cannot be's. Do you have questions? Because are you dealing with a radical, a square root, or are you dealing with a denominator? So great question. Square roots will be greater than or equal to, but underneath the denominator is cannot. Valid question. Okay, here we go. Next one. The domains won't be the same necessarily, so let's do this one. This would be f into g. So this will be different. F into g. So what we're looking at is 1 over 3 over 1 minus 2x. I'm going to have 2 bulletin points. The first one comes from this denominator. So we would say 3 over 1 minus 2x cannot be 0. The next one would be that denominator, am I right? 1 minus 2x cannot be 0. Solve for x in each case. Solving for x right here will be interesting. We will cross multiply 3 times 1 and then 0 times 1 minus 2x. Denominator's gone. So we have 3 equals 0 times all that stuff is 3 cannot equal 0. Is that going to happen ever in our domain? No, that's like a random, weird, not true statement. That's not going to be an issue. We don't have a variable to restrict. Yeah, it's true, good point, but it's not going to happen. Good point. Okay, solve for x here. Subtract 1. Negative 2x cannot equal negative 1. So x cannot equal, divide by negative 2, people. 1/2. So my only restriction was x cannot be 1/2. So my final answer, since all other x's can go, would be negative infinity up to 1/2. Union 1/2 up to infinity. Is that making more sense today? Yeah. Sweet. Okay, let's keep going. Let's do some extra advanced domain ones. Once again, I'm only focusing on domain. I'm not simplifying any of these. Okay. There is 4 potential issues here. There we go. Let's look at our first one. Isn't my first issue there? So make bulletin points. I do, to keep it straight. So we'd say x minus 2 must be greater than or equal to 0 since that's under a radical. Next potential problem. That the square root of 1 minus 1 over x cannot be 0 because that's a denominator. Next potential problem. That 1 minus 1 over x must be, greater than or equal to 0. And then we'll put it all together. So some of you can piece it together in your head, but some people can't, so I'm just leaving it separated. And then isn't my last one right here a restriction because it's a denominator? So x cannot be 0. Okay, let's go through and solve all these, then put all the domains together where it works for all the pieces. So here we go. Isn't my answer here, x must be greater than or equal to 2? Let's write it in interval notation. So from 2 to infinity right now. I'm going to put a little star. We'll come back to that. Now solve here. Square, square. Root cancels out with power. 1 minus 1 over x cannot equal 0. Subtract 1. Negative 1 over x cannot equal negative 1. What would I do next? Algebraically. Yep. Negative 1 cannot equal negative x, so x cannot be 1. I'm going to put a little star because we've got to revisit that in a second. Solve for x here. Subtract 1. Negative 1. Actually, I personally am going to go about this a different way. There's many ways to do this. I'm going to add that over. So I have 1 is greater than or equal to 1 over x, right? Now I'm going to multiply both sides by x. But you would have got the same answer depending on how you did it. X must be greater than or equal to 1. So wouldn't that be like this? Bracket 1 to infinity? when you divide by a negative. So if you would have done this by subtracting that, we would have had negative 1 over x is greater than or equal to negative 1. Am I right? Then you would have multiplied both sides by x. You would have negative 1 is greater than or equal to negative x. Then you would have had to divide both sides by negative 1, flipping the inequality. 1 is less than or equal to x, so x is greater than or equal to 1. Okay, so now we have this little star, and then we have this little star. Okay, let's look at all of our stars. So look, my domain here was from 2 to infinity, correct? So could I have a 1 in that one's domain? No, it starts at 2. Guys, think about it. 2 to infinity. Is 1 included in that one's domain? It's got to be included in all. So we can now go to this and cross it out. That's not 1 to infinity. Can't be 1, because that up there said so. Now next one, right here it says x cannot be 1. Now look at this. Isn't that taking care of that for us? From 2 to infinity, x can't be 1. It won't be in our domain. Now look, x cannot equal 0. Will that even be in that domain? No. So our final answer that contains all of the above would be our domain officially for this one would be 2 to infinity. Does that make sense? What's the question? Yes. No, it can't be. It won't be. Because, sorry, great question. No, it wouldn't go to 1. It's like 2 is the lowest value we will be. That will meet all the criteria. Because 2 is fine in this domain, correct? It's just 1 wasn't fine here, so 1 isn't going to work. Does that kind of make sense? So it's got to work for all of them. Okay, gotcha. Okay, let's do another one. Here we go. Couple more. I'll let you do the next one completely by yourself. So looking at this one, you guys, let's see if you can pick out the possible restriction. Bulletin point. X squared minus 9 must be. Okay, I'm going to give myself some room. My next one, my next restriction, my next problem would be right there. So it'd be true to say 1 plus 1 over x cannot be 0. And then my next restriction, x cannot be 0. So I'm going to just circle that one for a second so that I can keep straight all of them, and then we'll put it together. Okay, let's solve up here. Now, because it's quadratic, we actually can't solve by just taking square roots when it comes to inequalities. So remember, we have to factor this out and then test intervals for x, which will work. Factoring this out to find the zeros, x minus 3, x plus 3 must be greater than or equal to 0. So now we'll draw our number line. We found our zeros, 3 and negative 3. And now we'll test to see what's in our domain for sure. Let's test a value below negative 3. Negative 4. Is negative 4 squared 16? 16 minus 9. Is that greater than or equal to 0? So yes, this part is in my domain. Let's test a value between 0. 0 squared minus 9. Is negative 9 greater than or equal to 0? That's not in our domain. 16, because I'm going to test 4. 16 minus 9 is greater than or equal to 0. Yes. So right now, for this piece, my domain is negative infinity up to negative 3. And then are these yeses equal to? So is that a yes? So bracket, union, yes here, bracket 3 to infinity. We're going to combine all these in a second. So I'm going to circle that. All right, solving for x here. Subtract 1. 1 over x cannot be negative 1. Now wouldn't I multiply both sides by x? 1 cannot equal negative x. X cannot equal negative 1. So now, guys, we have to piece this, and this together where it works for all of the pieces. So now think about it. Think about it. Negative infinity up to negative 3. There's nothing in these two things that would prevent that, correct? So 0 is not in that interval. Neither is negative 1. So, yeah, we're good there. Negative infinity up to negative 3. Union. Now think about it. Isn't negative 1 going to be in this interval that we said no to already? So we don't have to worry about that one. It's taken care of in our no. Now right here, is 0 going to be contained in this interval of no? So also we don't have to worry about that. That's taken care of in this gap. So then there's our final answer. So we once again know that that's where the asymptote is happening. At -3 and at 3, right? Questions? Okay, cool. Okay, you guys try this one by yourself. Were you able to get this far on the inequality yet? Do you have the right less than sign? Or do you have the greater than sign? Sweet. Keep going then. So you were able to get this domain then? And were you able to get this domain? And then right here, it's another quadratic. You got to factor, find the zeros, test. And so then in this one, we have... But then we will piece it all together, obviously. I have not done that part yet. Okay, before I piece it together, I need everybody to be like, okay, I understand where you got each of those separately. So he's asking, why do I have to solve this quadratic inequality by a number line? Yeah, so what would happen, Jonathan, if we tried to, let's say we subtracted 4, for example, and we got negative x squared is greater than or equal to negative 4, so we divide it by negative 1, right? So then we would have x squared is less than or equal to 4, so then if you square rooted both sides, you would get this. X is less than or equal to plus or minus 2, and that's some weirdness going on. So we can't solve, this is why, that's a valid question. We can't solve quadratic inequalities by this method. Only linear can be that straightforward. So instead, because we can't solve by that method, we're going to solve by testing intervals to see which is truly in our domain. So we find, because it's equal to 0, we find the zeros. So we factored, found the zeros. And then what we can do is we can go through and test values down here, like testing -3. If you plug in -3, -3 squared is 9. 9 minus 4 is 5. Is 5 less than 0? No, so that's why I put no here. It's not in our domain then. Does that make sense? I tested a value in here like 0. 0 minus 4 is negative 4 less than or equal to 0. Yes, so that's in our domain. And then we got a no here. So our domain was from negative 2 to 2. Okay. All right, let's connect these dots now. We've got to put this into one final answer. So everybody look. Can we be from negative infinity to infinity if we're only allowed to have negative 2 to 2 here? No, so that's gone, not true. Now look, from negative 2 to 2, all is good, but in between there, isn't 0 in between there? Yeah. It can't be 0, so we've got to connect this domain together. So isn't it true that the lowest value we can have is negative 2? Then we're going up to 0, but it can't be 0. Union, then from 0 we start again and go up to our greatest value of 2. And there's your final domain. So hopefully that helps, because I know that was hard. Is it making more sense today? Awesome. All right. Okay. So we're doing now 4-5, which is inverse functions. Everybody listen, we really have a lot to cover. So everybody, we know that if you have a function f of x, you can plug something in, like 3, for example, right? And then aren't you going to get something out? So functions work by plugging something in, we get something out. So input and output. So everybody, input would be the domain of the function, or x values. And when you plug something in, you get something out. That's output, which would be the range of our function, or y values. So everybody look at this like red circle. I'm just trying to get this idea across to you. So if this is my input here, then this would be considered my domain. Is everybody good? So let's say I take some function and plug in 2 to it. And I get out my range, right? My output here, I get out 3. So let's say I have a function, I plug in 2 and get out 3. Well, what's going to happen, so that was the original function. What's going to happen is, if you take an inverse function, what will happen is, now if we plug in 3, which was our output here, if we plug in 3 into our inverse function, what's going to come out is 2, the original input. So what I want you to notice, guys, between the function and the inverse, do you see how the original function's domain will be equivalent to the inverse function's range? Let me say that one more time. That didn't work out what I was meaning. Sorry. So what we did was we plugged into and got out 3, everybody. Well, then we can take and plug in 3 as x, and we will get out 2. So what I meant to say was, of the original function, if we get x equals 2, and we're plugging that in, then that is going to be equivalent to the output on our inverse. Does everybody see? Okay, that's how I meant to circle it, like this. You see? So look, what that means is, if we have an xy point on a function, the inverse function will be switching x and y comma x. So look, the domain will be the range of the inverse. You see? xy, isn't y the inverse, everybody? I mean, the range. Okay. And look, the domain of my inverse will be the range of the original. So keep that in mind. Okay, so everybody, it says find the inverse. So if we have a set of xy points, how do we find the inverse points? Switch x and y. The domain becomes the range becomes the domain. Did everybody hear that? Okay, we switch them then. So this would be -1, 0, 0, 2, 2, 3, and 3, 4. Pretty easy, right? Yeah. Okay, what I want you to do is grab a graphing piece of paper on your desk, make yourself an XY chart. I want you to plot the original points Plot the inverse points and then tell me what you notice. Okay, you guys are all saying it in a correct roundabout way, and then these guys hit it right on the dot. You all said, okay, I'm seeing it's a reflection, so then I asked for more detail. Oh my heck, they always Yep. So, a lot of you were saying, oh, it's a reflection. So then I said, well, what do you mean it's a reflection over what? And then some people said, well, there's a line. And then I said, can you write an equation for the line? And so then other people said, yes, it's y equals x. Now look, how do we graph lines? Slope, y-intercept. So look, y-intercept is 0. Slope up 1 over 1, up 1 over 1, up 1. Do you all see? Inverses will always be, take those xy points and reflect them over the y equals x axis. So that should be the first, really the second note you should have in your notes. The first one is we switch x and y points to get inverse points. Second thing to know is inverses are going to be a reflection over the y equals x, which makes sense, everybody. Look, right here's my original xy, and then doesn't y equal x in the inverse? It's making sense. Everybody good? Okay. Now watch. Look. They map evenly. They map evenly. That's a reflection. They map evenly over that line. They map evenly. So it truly is a reflection, like a stamp across that line. I will ask that again on a quiz / possibly on the test. So next thing. So we know that if you switch xy points, you can find the inverse. Second, it's a reflection over y equals x. And third, here is how you find the inverse of an equation. So here's just how I write inverse f inverse of x. That's like a little -1, but we read it as inverse of x. So here are the steps. Your first step is to use algebra to find the inverse of an equation. You first switch x and y in the equation. So if you originally have y is equal to 2x plus 7, you would switch x and y. X is equal to 2y plus 7. Second step, once you do that, solve for y. So now we're going to try and get y alone, piece by piece using algebra. So we would subtract 7, divide by 2. Now y is alone. We have found the inverse. Now what you would do is your third step is write it in the prettiest format and change it to the correct notation, f inverse instead of y. So look, I have f inverse of x is equal to 1/2 x minus 7/2. Well, why did I write it like that? Because if I asked you to graph it, what do you want it to be in mx plus b form? So instead I did 1/2 x minus 7/2, just to put it in the prettiest format. Okay, so those are the steps. So let's do this one. Look at my first example. It says, find the inverse of the function. Let's do it using algebra. So my original function is x squared minus 1. So to find the inverse, right now we have this. Y is equal to x squared minus 1. First step, switch x and y. Second step, solve for y. So what should I do? Add 1. Now, what would I do next? Square root of x plus 1 equals y. Now here's one thing I'm missing. I have a quadratic here. Let's graph it. This is a quadratic that was shifted down 1. So look, I would shift down 1. Now if you didn't know how to graph it, you could plot points always. Plug in 1, that would be 0. Plug in 2, what would we get? And then plug in 3, what would we get? Okay, good. So now look at this quadratic. Well, this needs to have a plus or minus then, because we have both the positive half and the negative half. Or think about it, when solving, with dealing with square roots, we need plus or minus. So the final answer is f inverse of x will be equal to plus and minus the square root of x plus 1. So there's our inverse. So when solving, we do an even root. We can't forget plus or minus. Now let's graph that. So when I switch x and y, everybody. So look, over 0, down 1. Wouldn't that be over 1? Let's write it out for the video. So over 0, negative 1 would be negative 1, 0, wouldn't it? That's the inverse. And then we have, on our original negative 1, 0, we have a 1, 0, don't we? So our inverse will be 0, negative 1, and 0, 1. And then we have over 2 up 3. So then we're going to have over 3 up 2. We have negative 2 up 3, so we're going to have 3, negative 2. So I'm just going to graph those points. Over 0, down 1. Over 0, or over negative 1 up 0. That's the one I should have graphed first. It doesn't matter though. And then over 0 up 1. Then over 3 up 2. Over 3 down 2. So we could draw that in. We could be as specific as we want. So my question for you is the inverse a function? Is not a function? No, because it doesn't pass the vertical line test. Do you see how at 3 there's 2 y values for 1 x? So this is an example where the inverse is not a function. So that is not a function. Let's see. Okay, now this is what you're going to want to do. So it asks the domain and the range of the original function and the domain and range of the inverse. Now everybody think about it. Didn't we just spend the first half of class 30 minutes going over how to find domain? Look for problems. So domain is way easier to find than range because we're not always going to have a graph to refer to because you don't want to graph everyone. So just look and find both of their domains. Because then don't you know that the domain of the original will be the range of the inverse? Because didn't we switch x and y, everybody? Does that make sense? Okay, let's look at the domain of the original. Do you see any problems? Any roots? Any division? No, so my domain here would be negative infinity to infinity. So what do we know about the inverse's range? Yep, because that is equal, isn't it? We switch them? Now look, let's find that, not the range. I like to look at domain because it's easier. Look at our domain here. What's the one restriction? X plus 1 must be greater than or equal to 0. So x must be greater than or equal to negative 1. So isn't my domain negative 1 to infinity? Well then, what's my range? All right, sweet. Now look, that really does make sense. Look at the domain of the blue function. Negative infinity to infinity. Look at the range. Negative 1 to infinity. It worked out, didn't it? Look at my domain of the red function. We said negative 1 to infinity. It worked out. And then my range was infinity to negative infinity because it's growing up forever and down forever. So it all worked out. Sweet. Do the problem. Okay, wait, never mind. We're out of lunch and then we'll come back. Okay? Something else. So notice, we decided, given the quadratic, its inverse would not be a function because when solving, we need a plus or minus, correct? So think about it. For even roots, anytime we have an even root and we're solving, anytime we have an even degree and we find the inverse, we'll have an even root, which will get a plus or minus. Those inverses would not be functions. Okay, look at these three with me, then I'm going to let you go for it on your paper. It says, find the inverse of the function. Is the inverse a function? So just watch. So the first, if this is my original, the first thing we do is switch x and y. X is equal to y cubed. Now don't we solve for y? Cube root both sides? So we have the cube root of x equals y. So my inverse as inverse of x was the cube root of x. Now it says, is the inverse a function? It was an odd degree, correct? Odd degrees don't get plus and minuses, do they? So this would be considered a function. There's not an overlapping. Does that kind of make sense, everybody? So yes, the inverse was a function. Now watch how easy domain and range is. Watch, this is awesome. We know how to find domain really easily. We look for problems. So what I'm going to do is go to the original domain. Do you see a problem? No radical, no division. So our domain is all real numbers. Now look, because we know the domain of the original of the inverse, our range will also be all real numbers. Now look, I like to find domain because I don't want to have to look at the graph. The domain, do you see a problem? Say no, it's an odd root. No, so our domain is all real numbers, so what's my range of my original? And guess what? If you graph both, you would see that this is really true. It's just a way of thinking about it without having to graph it. Okay, one more. Let's do this one. We would switch x and y. So we have x is equal to 3y squared over 4. What should I do? Times by 4. So we have 4 equals 3y squared. Then what? Divide by 3, everybody, don't you? Then we would square root both sides, wouldn't we? Don't we need a plus and minus? F inverse of x is equal to plus and minus the square root. Oh, no wonder you're all just like, what is going on? That's what was, I was like, why are they all being silent? That's why, right? We're like, okay. So 4x over 3. Okay, is the inverse a function? Plus or minus would mean, think about a quadratic. If we have a quadratic and we flip it like this, it's going to be, no, the inverse is not a function. Now look, let's do the domain and range. So the domain here, any problems? Nope, all real numbers. So my range here must be all real numbers. Let's find the domain here. There is a problem, isn't there? So we'd say 4x over 3 must be greater than or equal to 0. So wouldn't you multiply 3 up? 4x must be greater than or equal to 0. So wouldn't you divide by 4? So x must be greater than or equal to 0. So isn't my domain here from 0 to infinity? Now look how nice that is, because what's my range here? 0 to infinity. I promise you, if you graphed it, you would see that this matches up perfectly. Okay, you guys do the ones on your worksheet now. Practice yourself. Ready, go. Okay, so.
No, I don't.
Okay. All right, so how do we find, well, first of all, I want you to look. Watch how easy this is. Find the inverse, state the domain and range. Let's just automatically right now state the domain here. Do you see any problems? Then it's negative infinity to infinity or all real numbers. Am I right? I'm not going to do range because it's easier to talk about domain. So let's find the inverse. Well, how do you find the inverse? Switch x and y, solve for y. So we have x is equal to 2y minus 1 squared minus 2. You tell me what I should do first. We have x plus 2 equals 2y minus 1 squared. What next? Did we just solve when taking a square root? Yes, so what do we need? Plus or minus. So we have plus or minus the square root of x plus 2 equals 2y minus 1, right? Now what? So we have plus and minus the square root of x plus 2 plus 1 out here. Then what? And that equals 2y. Sorry. Then divide by 2. Now look, watch. I'm going to write this in the prettiest format. Now think about it. Isn't this divided by 2 the same thing as multiplying by a half? So I'm going to rewrite this as plus and minus 1/2 square roots of x plus 2. Do we agree? Plus 1/2. And that's equal to y. Now look, y's alone. So you would instead go like this. F inverse of x was equal to plus and minus 1/2 square root of x plus 2 plus 1/2. Is everybody with me? Okay, now look. We are going to find the domain of this. Where's the problem? So our domain here would be -2 to infinity. Well, look how nice that is. Then what was my range here? -2 to infinity. Then what's my range here? Yep, all real numbers. Okay, cool. Moving on. Does that make sense, everybody? Okay, let's do another one. Switch x and y. Now I'm not going to do domain. Well, yeah. So switch x and y. So we have x is equal to the cube root of y minus 1. Solve for y. So cube both sides. X cubed equals y minus 1. Then what? So we have x cubed plus 1 equals y. So we would say f inverse of x was equal to x cubed plus 1. What's the domain here? Any problems with odd roots? All real numbers? So then my range here will be all real numbers. What's the domain here? Any problems? All real numbers. So my range here must be all real numbers. Pretty simple. Okay, now let's just do algebra. So watch, the algebra is going to get harder. Here we go. Switch x and y. I hope you're watching. So we have x is equal to 2 over y minus 1. What should I do? Do what? I wouldn't divide by 2, but that's me personally. There's many ways to do it. It's not that that's wrong, because algebraically that's sound. I personally would multiply both sides by y minus 1. So now look, that divides, not that you were wrong, because your algebra could have worked out perfectly if you did that, because you were right. You could have done that. So we have y minus 1 times x equals 2. Am I right? Yeah. Now, people get caught up here in what's the goal? The goal is to get y alone. So what should I do? So we have now y minus 1 equals 2 over x. Then what? Yep, so f inverse of x equals 2 over x plus 1. Done and done. Let's move on. Let's not do domain risk. Let's just move on. Okay, watch, because this one you will see again on a test and on the online homework, and it always gets people. So switch x and y. X equals y minus 3 over y plus 2. Now here's the problem. We have two y's, don't we? Okay, well, first of all, yes, we do. But second of all, I'm going to first get rid of fractions. So how would I get rid of my fractions? So those divide out. So I have this. Y plus 2 times x equals y minus 3. Now remember, we're trying to get y alone. There's a y and a y. Now we can't do anything unless we multiply first this in. Because what comes before addition? Multiplication, obviously, right? So let's multiply x in. So we have xy plus 2x equals y minus 3. Now, anybody have any ideas of how we could get y just to be one y? By factoring. He's right. Well, we can't factor without having something in common. Look, do you see anything in common? Okay, no, we're not going to do that because we end up back here. What's our goal to get y alone? So that was a bad question. What we're going to do is get all the y's to one side of the equation and everything else to the other side so we can factor out a y. Okay, subtract y. So we have xy minus y plus 2x equals negative 3. We cannot factor out a y because of the 2x, so we need to move that over. Xy minus y equals negative 2x minus 3. Is everybody with me? Now I can factor out a y. So then divide by y, what's left? And that's equal to negative 2x minus 3. What's my last step to get y alone? So we have f inverse of x equals negative 2x minus 3 all over x minus 1. Hallelujah that that's over. Questions? So here's the rule. If you have two y's and you have to solve, get all the y's on one side, everything else on the other side, and factor out a y. Okay. All right, now here's what I'm going to have you look at with me. One last one that I'm going to let you practice. So this is very interesting here. So far, we've only found inverses with squares and had to find square roots, didn't we? And had to put plus or minuses. So watch what happens if it's the opposite. So it says, consider the function f of x is equal to the square root of x minus 2. What are the domain and range of the original function? Well, you have to know how to graph these. So this is shifted, I hope you're listening, right 2. And then there's nothing added out here, so it was shifted up or down none. So everybody look, right 2. Now look, we can plot points to graph this. If you plug in, we know our domain is from 2 to infinity. Plug in 3. 3 minus 1 is? 1. Square root of 1. 1. So over 3 up 1. Do you guys see what I'm saying? If you don't know how the pattern works. Now look, if you plug in 4, it's going to be a decimal because that's the square root of 2. If you plug in 5, that's the square root of 3. If you plug in 6, square root of 4 is? 2. So over 6 up 2. Okay, that's good enough. I'm going to graph this. Okay, that is the function. It says, find the inverse. So let's find the inverse. So algebraically, we would go like this. X is equal to the square root of y minus 2. What would we do next? X squared equals y minus 2. Then we would have x squared plus 2 equals y. Am I right? So f inverse of x is x squared plus 2. Now here's the catch. That is not really the full inverse. Think about if you graph this. If you graph this, guys, it's going to look like this. Was it the top and bottom half of the quadratic? Look at the original. Should it be both? No, the original wasn't both. So this is not the full inverse. Don't we only need the inverse for the top half? Yes, so everybody, this is how you think of it. You would say, okay, this is my inverse, but only for x values from 0 to infinity. So you'd say this is my inverse for x values greater than or equal to 0. If you don't put that, it will mark it wrong on the online homework. Because that is not the inverse for all of x. It's only the inverse for x values greater than or equal to 0. Now here's a way to do it without graphing it. So everybody listen. If you have the original function and you find the inverse, which is a quadratic, you would first look at the domain and range of the original. So everybody, the domain here is 2 to infinity. Now you would not be able to use that trick we used a second ago of looking at the domain down here, because that's what we're trying to figure out. So the range here is what you'd want to look at. So range, look at the picture. Wasn't it shifted up and down 0? Right? Plus zeros out here, isn't there? So there was no shift up and down. Look. So my range is from 0 to infinity. So my range was 0 to infinity. Now don't we know that this is the domain of the inverse? So look, this is our inverse for x values greater than or equal to 0. Did you see? So let me change the problem, because I had somebody ask a valid question. So they said, so if this was plus 4, what would my range have been right here? 4 to infinity. So this would be our inverse for x values greater than or equal to 4. Does everybody see how that's working? And if you plotted the graph, you would see that that's true. Look, wasn't that true, everybody? Okay, cool. Well, for the 0, it was true. Okay, ready, set, go. Do these problems. Flip to the back page and do 23 through 31. Everybody look at 28. You have this. F of x is equal to the square root of 3x. So what's the inverse? X squared over 3 equals y. But we gotta have a restriction, right? Because this, think about it, is there a shift left and right? No. Is there a shift up and down? So it looks like this, correct? So now think about it. If we inverse this, my domain here would be 0 to infinity, wouldn't it? And my range is what we really want for the restriction, because that would be our domain of our inverse. So isn't my range 0 to infinity? 0 to infinity. Now that's the domain, right here is the domain of our inverse. So that's our inverse for x values greater than or equal to 0. If you don't put that in, you have the wrong inverse. Because you would have both. We only want this part of the parabola to make it the true inverse. Okay. Sweet. Hey, everybody look. There's this cute little word you're going to see, and the word is 1 to 1. So they're going to say, is your function 1 to 1? So here's how you know. So we know to make something just a function in general, that every x value can have only one y value, correct? So what makes a function 1 to 1 is that also the function is a function, but also your y values also only have one x value. So what would that mean? Correct. So if you have a function and its inverse is also a function, that makes it 1 to 1. So if I said to you, is this function 1 to 1? What you would do is find the inverse. If that is yes, that's a function, then yes, it's 1 to 1. If it's no, it's not 1 to 1. So for example, look at problem number 12. When you found the inverse, you got plus and minus the square root of x minus 3. Is the inverse a function? No. So that means that x plus 3 squared is not 1 to 1. Okay. Yeah, you say it's a function, but it's not a 1 to 1 function. Okay. Everybody listen. So, here is what's interesting. If functions are truly inverses of each other, then this will be true. I'm just going to cut right to the chase. If functions are truly inverses of each other, then f of g of x will simplify to be the identity function x. And if they're truly inverses of each other, then GOF of x will also algebraically simplify to be x. You got to check both. Now, so I'm looking at this problem and I'm saying, are these inverses? Now, obviously, you could just say, well, I'm just going to find the inverse of this and then see if it matches up. That's not allowed. On the test, it's showing the work. So I'm adding in. Use function composition to show. So we would have to do it like this. So you'd show both. Look, this one's G plugged into F, isn't it? G plugged into F. So this would be 1 over x plus 1 minus 1, right? Now we would simplify it. So isn't that equal to 1 over x? Which simplifies. Everybody listen. On top, 1 is technically 1 divided by 1. Divided by 1 over x. Dividing fractions is easy as pie. Flip the second and multiply. Okay, look, it did simplify to be x. Let's check the other one. Now we have to do f into g. So we would do this. 1 over x plus 1. No. I'm plugging this in right there. So 1 over x minus 1 plus 1, right? Now look, rewrite this as 1 over 1 divided by 1 over x minus 1 plus 1. Doesn't this simplify to be flip the second and multiply? So then we would have that's equal to, this is the work you would need to show, isn't that x minus 1 plus 1? Which equals check and check. Yes, you do. Because sometimes one will work one way and it won't work the other way. So you say, no, they're not truly inverses. Okay, let's do this one. So you would say, it says use function composition. So let's plug this in there. So we have 3x plus 2 minus 2 over 3, which equals 3x over 3, which equals x. We got to do the other way too. This plugging in here. So we have 3 times by x minus 2 over 3 plus 2. If you do this and your algebra is wrong and you just happen to get it right, I'm marking it wrong. So think about simplifying this. Isn't that 3 over 1? Doesn't 3 divide by 3? X minus 2 plus 2 equals x. So it really does work. All right. See if you could do this one. If I asked you to find FOF inverse of 2. Tell me what you do. Ready, set. So in this one, we obviously need F inverse, don't we? Let's find that. X is equal to 3y. Solve for y. So F inverse of x equals x over 3. Now rewrite this. Squish 2 back in with F inverse. That's F inverse of 2. Don't we squish it in again? F of F inverse of 2. How do we find F inverse of 2? Plug in 2 into F inverse. So what would we get? So now we're looking at F of 2/3, which is, plug 2/3 into F. 3 times 2/3, which is 2. Pretty easy. Okay, practice whatever you want. Do a couple on the worksheet in the last 5 minutes of class, and then you do the online homework.